Okay, folks, good afternoon. So, today we'll study some of the layer 2 attacks. When we say layer 2, primarily we are interested in Ethernet. Okay. We'll look at CAM overflow attack, and if time permits, we'll go to DHCP attack. Okay. Please feel free to ask me questions, and most of the contents I have taken from these sources. Okay, so yesterday I've sent you an email about Aadhaar card leak, right? Would have received, only 2 students have responded. Okay, do you have Aadhaar card? Is there anybody who doesn't have Aadhaar card? It's like social security number for us, right? It's the ID card that works everywhere within India. Okay, and it has been stolen by someone, and that person claims to have ID as PWN0001, and he has stolen so many records and is asking for about $80,000 for this record to be available to anybody who wants to pay. And after some time, this price will drop because the one who is buying may possibly sell it to others, and eventually after some time it will be available for very cheap price. Okay, now it's a problem. This is not the first time. This is second or third time possibly happening that Aadhaar database is leaked. Earlier COVID data was leaked. COVID data means that the people who registered for COVID tests, etc., or vaccine, etc., or all the records of those people were leaked. So now this data is leaked. So now surely your data and my data also, everyone's data is available in dark web. Okay, and of course there is a price. So the intent of these cyber criminals is to steal their data and sell it. Okay, so that we know, right? So what has been lost so far? Of course, is 80K is the initial price. Okay, and why should anybody buy this? Enemy country, of course, can always buy and try to do something about it, or maybe cyber criminals can buy it. Okay, so what does it include? Whatever you have submitted in your Aadhaar card, right? When you make Aadhaar card, they ask everything, right, about you, your name. All this available in plain text, by the way. It appears to me. Okay, see, what are the ways in password file we store passwords? We stored in hash form, right? You know this? Another way of keeping this kind of data is encrypted. There are 2 ways, right, of keeping data securely. Like your hard disk, you encrypt. Most of the companies mandates employees to encrypt the complete hard disk. So if it's stolen, until the threat actor has key, cannot decrypt it, right? This is normal encryption that we have studied in the class, right? Okay, like AES, DES kind. So data offered include name, father's name, phone number, other numbers, passport number, Aadhaar card number, your age, gender, address, district, pin code, state, and biometrics. Biometrics can also be misused, right? You know this. Okay, Now the question is that I've asked you yesterday, what can you do? You cannot prevent somebody from stealing this data from any database, right? Or Aadhaar database or some other database. It will happen in future. How do you handle this? How do you protect yourself and your family members and friends and everybody else? Yeah, please answer. Yeah, anyone can answer this. Is there a way to protect yourself? Is that data somebody who is going to buy this data? Is that person buying it for fun? There is a money, and there is a if getting up to 80K will make few millions out of it, right? How will it make millions?
Like that person can do identity theft against us. Like he can do something bad and use our name for it.
Yeah, so that's very good. So maybe somebody can pose as somebody else and do some criminal activity, and then get free. And somebody can make Aadhaar card from this data, a duplicate or some Aadhaar card with his own photos inside that, and show in an airport and then fly and do something. A lot of mischiefs can be done with, if a cyber criminal knows your identity or somebody's identity, and identity stealing happens, right? Somebody can pose as you and can do some activity. What else? Very good. So that is what you said is criminal activity, right? But you know there is a money involved, right? And majority of thefts or cyber crime happens because of the money. Money is a big attraction for criminals, right? Some people, some do it for fun, but mostly for money. Does it help in hacking your account? Okay, by the way, there will also be some more information, possibly some bank. See, bank details, you will have a primary bank, the account number, etc., are also linked to Aadhaar. I'm not sure that data is also gone or not. If that, you know, because when you file income tax, they want to validate that it's you who is doing it. So they do it through, you know, I mean, you can do it through Aadhaar, and where the bank is also linked, right? So some of these things, if this linking is there and they've got bank details, it's much simpler for them. See, this data is good enough to give a cyber criminal confidence to fool you. Okay, yesterday I have received a phone call from, and these cyber criminals are very smart, huh? Very smart. And this somebody is posed as a woman, employee of Bharti Exa. This company is NBFC. Is basically a financial institute, non-banking finance company. And then she told me, and she said her name is something like very good, nice sounding name, like Priyanka Agrawal, for example. Now, when you hear this name, I will have some level of trust because she belongs to same community as what I belong to. So basically, she has done, or her company has done this study, that this is the first level of trust, and she spoke fluent English. She said that I have a dormant account in Bharti Exa, wherein I have taken in 2014 one ULIP, which is essentially investment linked to insurance, and I have paid 50,000 rupees, and after that I have not paid any money. Okay, now that 50,000 has become 1.95 lakh, and she wanted me that why I have not paid remaining, whatever, the only first remaining installments. I said that I don't recall that I have taken it. And she says that maybe somebody else has taken on her behalf. I said, nobody will take it on my behalf. And she, this is your policy number. Please verify, check your emails. You would have received emails. Uh, I knew that it's a fraudulent call because I will never buy ULIP. ULIP is actually way to fool anybody, right? I mean, insurance, life insurance plus mutual fund combined instrument, right? There are two things which should be sold separately, but that these companies try to fool. Anyway, so I realized that then I further probed her, and so on and so forth. And then she says that, you will have to pay a penalty of say 50,000 rupees, then we'll release this. I said, can you send me an email? Now I wanted to authenticate who is she. Okay, remember that we have studied authentication is a very important mechanism by which at least 50% frauds we see in life can be avoided. In fact, I would say that a common person can handle at least 90% frauds with this one. Okay, so first thing is that I asked her that you are from the bank, can you just do video call and show me your ID card? Then she said that she is not allowed to do video call. I said, fine. Then I said, do you have email address? She said, yes. I said, please send me an email address from Bharti Access account. Okay. She said, no, right now I don't, I have only Gmail. I said, okay, send it through Gmail, right? She said, no, my machine is not working. I cannot send any email, right? But why are you asking for that? You must, why don't you trust? Then she says that I can tell you about you that you have your mobile number is of course in which I am calling. Then she told me that my address is the following. Okay, well, wherever I live, that's also correct. Then he said your email address is this. Now, do you trust me? I said no. Until you send me an official email, then I will not never trust you, right? Then she disconnected. Now, this is very clearly that authentication, if you tell your parents and friends also, through authentication, you can avoid authentication of whom? Authentication of calling party or criminals, right? Who are doing these mischiefs. Because now they will try to win our trust, right? But because, just 10 years back, I would have thank you very much for calling, a lady is calling, you will have already respect for her and, all that, right? These are all tricks. Whoever is calling, maybe you're actually you're receiving call from your bank, say IGFC or ICICI or whatever bank. You should ask for authentication. You should say that, can you please call from landline? And secondly, can you please WhatsApp your ID card? Otherwise, just don't take call. Actually, in fact, you don't take call. It does not harm. Okay. Now, coming back to this Aadhaar card theft, of course, we have all lost our identity, details of our identity, right? So privacy, in some sense, is anybody can now call us anytime. Okay. And also they have a lot of these things available, this data available. They can think of a lot of frauds, right? Like online banking frauds. This data will help them. E-tax return fraud, some other kinds of fraud, phishing attacks, identity stealing, and so on and so forth, right? I mean, they may call your father or grandfather for that matter, okay, who's not aware of all this and can say that I'm calling from bank. Your bank account has some issues. We want to resolve it. then you'll say your name is this is your mobile number, your address is this. Your grandfather possibly say yes, all this correct, and he will have faith on the caller and then possibly pass on OTP. Okay, so please be aware of that. There are a lot of ways this data can be stolen. What can you do about it then? Of course, the first thing is that don't entertain calls from unknown people, and also emails. Just delete these emails, right? And always authenticate the caller by number of means, right? You can ask for all the details, and don't think that you're doing anything wrong by asking. Okay, and then possibly you can change the data in your Aadhaar card, but this is not going to help, man. After a few years there will be another data breach. Okay, important thing is that possibly most of the websites you set a strong password. By now you know what is strong password. Strong passwords are those which cannot be broken easily by any method, right? Okay, have at least 10 character long password with mix of uppercase, lowercase, special character, and so on and so forth. That's maybe even longer. It's very difficult to break, and have multiple level of authentication, right? Along with your password, you should have OTP, or you should have some code that's coming on some mobile app, and so on and so forth. Just think about it, how to protect yourself in such situations. Okay, all right. Okay, so let's get back to Ethernet now. Note that one important thing about all this is that what we are studying is very, very elementary, but it's good enough to protect yourself and your family members from cyber threats. So your role also is not only to study and get marks, but also to spread awareness about it to whomever you can, right? To your community, to your friends, or maybe in your, if you belong to a small town or even a big town, you go to institute or wherever and give a talk on this. Okay, so that people become aware of all this. Okay, so we studied about Ethernet. Okay, this is Ethernet that we use, and we call this is a switched Ethernet. Okay, and there is a switch in the center. When we say in center, essentially we are forming a SAT topology, but switch can be in a corner of a building and the wires can run to different places, so doesn't matter. It's the same structure, right? Now, here, each machine will have Ethernet card or Ethernet, and so there will be Ethernet address, say 1, 2, 3, 4, and so on and so forth. Whatever number, right? So this is 48-bit address, Ethernet address, assigned by card manufacturer, or you can code it also or program it. Okay, so note that in networking, every device needs to have a unique address. Otherwise, communication is not possible. Okay, so now all these in a room, you have multiple machines, each will have a different Ethernet address, and one machine at layer 2 can send Ethernet packet to other machine, any other machine. Okay, very simple. So now in order to communicate the machine, if machine A is sending it to machine say C, then it should know Ethernet address of this machine A should know Ethernet address of C. Otherwise it cannot communicate. Okay, now that's the assumption. So there are ways to know Ethernet address of other machine. Okay, so right now we'll not look at that protocol, but note that for communication, destination address is required. Okay, now we have studied of CSMACD. So this also uses CSMACD, but no collision. Okay, now note that this mechanism is self-learning. When we say self-learning, when A is sending packet to C, then this switch will know I will have to send this incoming packet to this outgoing link. Okay, when A sends it to D, the switch when receives this frame looks at address D, it has to send into this one. Now this learning is called self-learning. It's a plug and play. Okay. So look at this one. So these are the, let's assume that these are the addresses A dash, B dash, C dash, or you can number it the way you want, A, B, C, D, E, F, G, H, or whatever. Okay. And this machine A, or we can say machine with MAC address A, is connected to port 1 of the switch, B is connected to port 2, C is connected to port 3, A dash is connected to port 4, B dash is 5, and C dash is to 6. Okay. Now this allows parallel communication, right? A can communicate to A dash, at the same time B can communicate to B dash, or C can communicate to C dash. Now that was not possible in case of thick Ethernet, we have seen, because it would have caused collision. So there's great advantage here that there's no collision. Okay. Now the question is that how when A receives a packet for A dash, sorry, A sends a packet for A dash, so how does switch knows that packet has to go to port 4? Okay. For that, it creates a table. We call it switching table. Okay. So it works like this. Okay. Source address is A, MAC address is A, destination MAC address is A dash. Okay. Now this switch will have a table like this, MAC address and the interface. Interface or port, we can say. Which port? Say A is connected, MAC address A is coming from which port? Okay, and this is basically this entry is only for limited time, because you know, if A moves to some other port after some time, then this understanding should go away. Okay, the earlier understanding, right? So there is always lifetime. Okay, this is called time to live. So A is goes to A dash. Okay, how does switch know that it has go to port 4? Okay, now initially I am assuming that it's known. Okay, so it can directly send. If it's not known, then we'll see how. So what happens that A is, now switch will, when it receives this frame, okay, I will go back. When this switch receives this frame here, then it knows that MAC address, this packet has come from A, right? MAC address A at interface 1. Then it says that it should be live for only 60 seconds or something like that. Okay, so now it has done some learning. Okay, okay, all right. So when okay, here when A dash responds back, then switch will learn that it's connected to 4. Okay, so now let's go ahead. Okay, so this is what it is. This is the algorithm, so please go through it. Okay, so now the algorithm works is this: source is A, destination is A dash. Okay, initially table is empty, this switch has booted up, so it does not know where A dash is, right? So this packet will be, okay, switch receives this packet, it doesn't know where to send, so what it does is it broadcasts it to all. Okay, it's like this. So only one learning has happened, that MAC address A is connected to interface 1, right? So if destination MAC address is not known, just flood it. You know, but this packet will be rejected by everybody else and accepted by A dash. A dash will respond back. So now the second learning will come, that MAC address A dash is connected to port 4. Okay, so this learning has also come. Okay, so in this way, as more communication happen, this switch will fill up with almost all all MAC addresses will come, or basically those who are communicating will come, and corresponding port number will be here. So once this table is available, then there won't be need for broadcast. If that entry is not there, destination machine has not communicated by anybody, then of course, whenever the communication happens, then they will be broadcast, right? So once this is available, this information is available for the second time. If A wants to send to A dash, then switch will simply send it. We will look at this table. We'll find out that A dash is at port 4. You'll send the packet to this port. Okay, all right. This is the way self-learning happens. Now these self-learning switches can be connected together in hierarchy, and the same protocol will work. Okay. Okay. Please go through this PPT, and then we'll learn. So both, somewhere now we are talking only about layer 2. This can happen in a small building or a small thing, right? But still we need IP. And then this switch is connected to a router to connect it to external internet. Okay. Or each department, for example, electrical engineering department can have also switch and router both, and so on and so forth. But so what is the disadvantage of having very large number of machines over Ethernet is that the broadcast is, whenever switch doesn't know about where destination is, it will broadcast to the whole network. So if suppose A is communicating to I, and then nobody knows where I is, right? So the packet, this packet will go to here, B, C, then it will come here. This also doesn't know, it will come here, it will go to D, E, F, then it will go to this place. It doesn't know where I is, it will go here. And here the I will respond back and the learning will happen. Okay, but there is a lot of broadcasts here, so it's not very efficient mechanism, but this saw is being used. So in order to reduce the broadcast domain, we can use routers, okay, somewhere or other. Okay, all right. So what is difference between switch and router? Switches work only at Ethernet level or layer 2 link layer device, layer 2 device, and routers work at network level or layer 3 or IP layer. Okay, all right. Okay, and this table in switches are created by self-learning. Okay, while tables in IP router is created using a routing algorithm like OSPF and so on, BGP, etc. Now the question we'll ask that why not? Layer 3 tables are self-learning or are not filled using self-learning. Can you answer this? Layer 2 we can do self-learning, but why not at layer 3? Anyone? Okay, think about it.
Computationally expensive.
Yeah, can you repeat please? Yeah.
Sir, it would take a lot of time.
Yes, it will take. See, the whole world's machines, how can you broadcast this? How can you do learning for the whole world's machine? The domain is just too large for learning, right? Okay. Now here in local area network, domain is very small, maybe 10 machines, 20 machines, 30 machines, but not billions of machines, billions of addresses. Then what will be table size? Suppose you start doing that, then table size will billions of entries. What will be searching time? Huge, right? So this will not work at layer 3. Okay, so Ethernet is connectionless, is unreliable. It does not say my packet will reach to other end. It does not give any guarantee. Okay, right? But it works. It works beautifully because usually it's reliable. I mean, although we say that does not give any, it's unreliable mechanism is unreliable, but technology evolved so much that maybe 1 in 1 million packets are in error or lost, right? Not even that much, right? Okay, all right. So, all right. So benefits are inexpensive, very cheap, right? For $5 you can get Ethernet card. Scalable technology, we know few megabits per second to few gigabit per second it can work. It can work with all kind of technologies, right? You know, copper, fiber, air, and so on. Okay, now Ethernet, what is the frame? Ethernet frame or Ethernet packet? Note that we don't use packet at layer 2. We use packet only at 3 and above. Okay, so packet looks something like this. Any packet will have source address and destination address, right? Even the laddu packet that you receive, your mother will write your home address or her address and your address. These are essential for any packet to uh, uh, reach to destination, right? And then third essential thing here is a type. You know, many courier companies insist to write what is inside. Okay, type says that what is inside this. This is the area where useful things are, like laddu, etc. Right? So what does it contain? Okay, she can write here sweets, right? But Ethernet, you are going to write whether inside is IP packet or IPX packet or something else. Okay, and the payload contains actual laddus or important things, right? And then there is CRC bits, which is for error correction, cyclic redundancy check to detect an error. If not correction, basically detect an error. If it detects, it does some calculation based on whatever it is. If the both don't match, then packet can be dropped by recipient. All right. So this source and destination address are 48 bits. Okay, all right. So that's all it is, right? So now we have this mechanism, switch Ethernet, switches in the center, and a pair of wires, one for sending, another for receiving, and there is of course a buffer, and there is a switch. Okay, crossbar switch or whatever. Of course, I don't want to go into this thing, but very important when you learn networking, then you'll say that, you know, there can be loops, forwarding loops, and that can cause broadcast storm. Okay, because you know Ethernet is based on broadcasting. Whenever it does not know where to send to, which port to send to, it just broadcast. And if there is a loop, then packet will rotate here or multiply indefinitely, right? So in order to do that, there is a protocol called spanning tree protocol, which was invented by Radia Perlman. And then you can read something about it if you want. Okay, so these are this is kind of Ethernet switches. This is what we use at home, kind of this, right? Simple ones. Now, what kind of threads we can think? Okay, note that Ethernet is also not designed for reliability and security. Not. Okay, so there can be various threats, right? And these are some of the one which we'll study are CAM overflow attack. What is CAM here? Anyone can tell me what is CAM? This word comes from computer architecture. At least let me know the full form of this. Okay, it's a content addressable memory, CAM. It's a way of implementing a table based on the content. You do the search rather than based on index, you do search based on the content. It's very similar to hash algorithm that you have, right? Okay, so let's look at, it's nothing but the table in the CAM form that we have in the central switch, where we have seen that there is a MAC address and the port number, and of course TTL, time to live. So this table is called CAM table, or for our understanding, we'll consider only table. Okay, and there are a lot of attacks are possible. That eavesdropping attack, row See, nobody stops in internet world or even Ethernet world for you to create a packet with any destination address and any source address. Now with this, you can do a lot of mischiefs. Okay, you can always pose as somebody else. You can send malicious frame with additional or change field. You can broadcast the messages, as many messages you want. You can do, you can overflow the packet table, this table that we discussed. You can do DHCP attack, we can do VLAN attack, right? So we'll study some of these, not all. The first one is called CAM overflow attack. CAM table, content address memory table overflow attack. Okay. This thing we know already, right? Is 48-bit source and destination address. Ethernet address consists of 48 bits. Okay. How this assigned, etc. Please go through this one. Now, content address memory table stores, or this table stores information such as MAC addresses, port number, etc. Okay. So, and this important thing is that these port tables are of fixed size. Okay, the table in each switch is of fixed size, it cannot be infinite size, and generally it's optimized. Okay, it can, otherwise switches will be very expensive. Okay, so this is a normal behavior. Okay, a packet is going from A to B. Okay, which is for use for ARP, for example, which we'll study later. Okay, so okay, so this packet will go to, and this switch does not know where MAC B is, so it will be broadcasted to all. Okay, ARP is address resolution protocol, which we'll study later. Just assume that A wants from MAC A, packet has to go to B, and switch does not know where the B is, so it will send it to all, right? Okay, and then B will respond back, and then this switch will now learn the B is connected to port 2. Okay, so this learning we have already discussed in previous slides, right? Okay, so this is a normal behavior. Now next time A wants to send something to B, now the switch knows that B is at port 2, it will send packet to this side. Good. So what will happen that now this important packet, this A is sending to B, is not seen by this guy, MAC C, which can be a malicious, a mallory can be there. All right. Now Mallory is interested that she wants to know. She wants to read all the. She wants to know what's happening between A and B, and wants to read all the packets. What can she do? Any guess? What can Mallory do here?
Mallory can change what the content in the packet is and send to the MAC B.
Yeah, she can do that, but that's very good. Basically, source, what you're telling is one attack that we'll study later is source address spoofing. All she can do is that she can spoof, or she can act like A, create a packet for A, and have spurious contents and send it to B. Yes, that's very good. What else? But here her intent is not that. Her intent is that Alice is talking to Bob. What Alice is talking, she is interested in just spoofing. Okay, one condition we know that when CAM table is full, okay, this CAM table, you know what A is sending to B, okay, for example, and communication has not started yet, okay, and all these entries are full. Okay, when now A sends to B, this switch will search for B's address in table, and these all entities are full. What will switch do? Switch will send this packet to everywhere, right? Okay, now Mallory will receive what? A has sent to B. Okay, so now we can have this attack that now Mallory can create. Now she has a software which will create fake packets and then it will change MAC addresses. Okay, okay. So basically, so attacker or Mallory connected to switch port flood the switch interface with large number of Ethernet frames with different fake MAC addresses. So she will create large number of Ethernet frames with fake addresses, right? Okay, and send it. So what will this switch do? Switch cannot just, switch doesn't know anything, right? It does not have intelligence that these are the only MAC address, because in switch people can come and go connected to switch, right? So MAC address could be anything, and there's no hierarchy in MAC addresses, right? These are all independent 48 bits addresses, right? So switch doesn't know. Switch has to create this table, right? So all these MACs, it means that it will create all these MAC addresses which through which different MAC addresses which Mallory is creating is sending it and have it port 3 or whatever. Okay, now MAC table is full. What will happen next? When the MAC table is full, now A sends it to B. Switch doesn't know where, switch does not have any entry available. It will do search, it will not find MAC address corresponding to B, it will flood. Okay. Now if it is, so the switch will act like a hub now. It will, whatever packet it receives from anywhere, it will just flood. And in the process, MAC-C will learn, we read the packet because it's available to her. All right. So this allows attacker to capture those frames which are not destined to it. So there are a lot of tools available. You can do experiment. Then MacOff tool, if you search, you will get it. All right. So now this is what it is, right? We have already discussed this. So we'll skip. So how can you prevent this? You will say that, okay, I will restrict number of MAC that we can have on a port, like we have seen the ports here, right? Ports. We'll say only 3 MACs can come. So basically, Mallory can create only 3 fake packets. But this size of table is very large, maybe 1024 or 2K, 2048 entries and so on, right? So now this is a solution. So now it means that now this table cannot be made full, right? So there's one simple attack. Now, you know about DHCP, we have studied in very brief. Anybody can tell me what is DHCP protocol? Okay, Alice goes to a cafe. Remember this, right? So we'll study these two linked layer protocol, DHCP and ARP. Okay, and both use broadcast. Okay, so now wherever there is a broadcast, then there can be security issue. Remember this thing. Okay, so now remember this diagram. Alice comes to say IIT Mandi, and then she comes first time. She's flying from US. She comes to your place, opens her laptop, goes to whatever cafe you have, and then she wants to connect. She wants to do Googling. Now she has come from US. The IP address cannot be assigned to her. She cannot use the IP address that she has used somewhere in San Jose, cannot be used here because IP addresses are hierarchical. So now she needs local IP address, otherwise packets cannot be routed to her. Okay, so what does she do? She does this protocol called DHCP. In order to get what? In order to get some information so that she can start communication, right? She needs IP address. What else she need? We discussed that time. she already has Ethernet address, right? Because laptop comes with Ethernet address. That she has. She needs IP address. She also wants to, if she does google.com or some other website, she needs to know domain, how domain converts into IP address. Because whatever we say, itmandi.co.in, it corresponds to an IP address. Okay, and there is a protocol for that. That's called domain name server, right? So it's IP address she needs, and also she, she wants to send the protocol packets to outside world. Then she needs to know the gateway router address, right? These three things at least are required. If somebody wants to get out of your campus, first thing, you'll say that go to the gate, right? Then gate has also some address here in case of IP, right? So these three things are needed. Okay. All right. So now DHCP protocol works in this way. The DHCP client is there in the local area network. So Alice's machine will shout to discover server that can help. And protocol is, of course, a dynamic host configuration protocol. Okay. So now she creates a discover message. She creates a discover message and broadcasts it over to on the net, local area network. When she broadcasts it, means it will be received by all, and then DHCP server is there. There may be multiple DHCP server. They will offer these parameters like, like IP address and other domain name server, default router server. They will say, okay, this is, you can use this. Second one will say, all right, you can use this, right? Then Alice's machine can select one of these. Okay. So it goes something like this. Here is Alice. She sends it this DHCP discover message that we have just shown here to over net, and DHCP server is there. Let's assume the one here. It responds. Let's assume that only one DHCP. It will say DHCP offer. This is the IP address and so on. Other information which you can use, all these things, right? IP address, gateway router's address, and time to live, etc., etc. Okay, or the DNS server also. So these three things have got to be there. Okay, so all this information comes to client, and she selects this. Okay, fine, this is good for me, right? So I have got information of domain name server, IP address of that. I got the address of gateway router. Okay, and so on, right? And IP address, of course. And she says, okay, fine, I'm good with it. Please allocate this to me. Now note that the DHCP server has offered, not assigned. So now Alice can now send a request, okay, please assign this to me. Okay, and this again is a broadcast mechanism. And as a result of that, the server will say, fine, I am allocating this IP address, etc., etc., for you, and you can use it for a certain period of time, or something called lease time. Okay, now tell me where attack can happen. Think about it. I have already given you a hint. Wherever there is a broadcast message, there is an issue. What is the criteria for Alice to accept one of the offers if there are multiple offers coming to her? There is no criteria. Whoever sends it first wins, right? Okay. Now, of course, okay. So this is the same thing is shown here. And please go through it. This is how DHCP message look like and so on and so forth. We are not going to get into it, all the details. Okay, the threat is there, right? Some kind of threat is there, and threat is because of this broadcast. Now it's listened by all, and Mallory also there in the net. There is a Mallory. This is a good server. They can also Mallory. What can Mallory do here? Multiple things she can do. What can she do? Multiple things, right? Tell me one thing that she can do.
She can read the messages
thing-
Alice is sending.
Pardon? Yeah.
Like after a DHCP attack is done, like Mallory can read the messages Alice is sending or whatever she is doing.
No. DHCP attack, I am asking how to do the attack, right? How Mallory can do the attack. The first thing is that she can prevent Alice from sending. So denial of service, right? How can she do that? This is called DHCP starvation attack. Okay. Now here is Mallory. Okay. Now this DHCP server, of course, has a limited number of IP addresses. This DHCP server will be given some set of IP addresses. Okay. How does it get? It gets it from some other server. Let's not get into some other router and so on. From basically from ISP. Okay. Now first attack is that if this Mallory can ask for, keep sending this request, DHCP request, with different addresses or randomized MAC addresses, right? Large number of MAC addresses she creates and keeps sending DHCP request. This guy DHCP server will respond back with a set of each message will responded with an offer, and Mallory will accept it. So she will consume the entire set of or entire scope of IP addresses. So entire DHCP scope is available now with Mallory. Okay, so it's like this. Attacker initiates DHCP starvation attack. She requests for DHCP discovery message. She sent discovery message, basically wants IP address and so on. And then this server responds and she accepts it and requests and so on, right? DHCP server acknowledges all requests. So she continuously sends this request and server will keep sending, and then Mallory will acknowledge it, right? Okay, or so on and so forth, right? It means that now she is able to grab all MAC addresses. Okay, then what is the countermeasure of this? Don't on a port, if request is coming on a port of the switch, then don't allow many such requests, right? Don't allow more than don't lease more than few number of IP addresses, maybe 3 or 4 or whatever, right? Don't allow more than that. It means that now if you do this restriction, then this gobbler or Mallory will not be able to grab all MAC addresses. And who can do this? Would this guy do it or switch will do it? It's done by switch. So you'll have to make switch little more intelligent and allow only certain number of such request or DHCP requests from on any port. Okay, and that's how we can save or prevent this attack. All right, so let's stop here. We'll go to another attack called DHCP snooping attack in the next class. Okay, any question? All right. Thank you. Then see you tomorrow.